6, 9.
So I'm going to give you another point.
1, 2.
The distance between from point A to point B is going to be 1 minus negative 6 squared plus what?
2 minus negative 9.
2 minus 9 squared, the square root. Distance from A to B. A to B, the distance from A to B. So that's going to be, what's 1 minus negative 6? 7 squared is? What's 2 minus 7? Sorry, what's 2 minus 9?
Negative 7.
Negative 7 squared.
Was that a really weird coincidence that happened with both people?
Yeah, it's just a coincidence. Yeah, it's just a coincidence of both 49. So what's that? The square root of 98. That's the distance between the 2 points.
Oh, okay.
What? No, it's not. It's not. Okay. Are we okay? Yay? No? Kind of, sort of, maybe?
Yes. Yeah.
Corresponding angles.
Corresponding. That's
2 pairs of corresponding angles are what? Congruent. Yeah, so B to E and A to D, for example. Okay, that's one way. What's another way? What's another way to prove similarity? Yes. And show what? All what are proportionate? Which sides? All 3 pairs of corresponding sides are proportional. Are there any other ways? I don't think we ran into any other ways yet, so we're going to really focus on these two. Before I launch you off into answering some questions about this, I want to ask you a geometry question. Funny that, it's geometry class. 2 things, really. If I had 2 lines like this, what does that notation mean? Yeah. Yeah, we'll call this line L1 and L2. L1 is parallel to L2. That's what those little arrows mean. Let's say I then did this. Let's say I did this and this, and I went da-da-da, like 2 of them and 2 like that. What does that mean? Those 2 are parallel. Exactly. No, if they're little marks, it means they're the same length. But those little arrows, yeah. Okay, does that help a little bit? So, let's say I label some more points. We'll call that point A, B, C, and D. Looking at that diagram, do you want to guess at 2 angles that are congruent? 2 angles that are congruent. Missy. Angle ADC, yep, is going to be congruent to what? Angle ADC is going to be congruent to what? I'm sorry, which one? CBA? Sure. Do people agree with that? You're telling me that this angle right here has to be congruent to? Do we agree with that?
Uh-huh.
Sure. Can you give me another angle? And I'm going to give you a strong hint here. I'll call that point Q, N, R, T. I'm just giving you some more points to talk about. Can someone give me another angle that angle ADC is congruent to? ADC is also congruent to what? Yes.
Angle NB and whatever the other line is. Like.
What?
Do you see where B is?
I see where B is.
The line going up.
Oh, you want me to label even more points? Can you give me something closer? How about over here? Stay over here. Angle ADC is congruent to what?
CBA.
Stay over here.
Oh.
QAD. Thank you. QAD. It's hard to see, but I mean this angle right here. This angle right there is congruent to that angle, which is also congruent to this angle. But I want to specifically look at this angle and this angle.
Oh, okay.
Those 2 are congruent. They are called alternating interior angles. Alternating interior angles are congruent. If you know that, another way to think about this is alternating interior angles. What's another, if this is one alternating interior angle, what's another, I gotta draw another point here. I don't know, we'll call that point F right there. What's another alternating interior angle to that angle right here? Yeah?
You mean, wait.
So you have angle ADC right there. Can you give me another alternating interior angle to that one?
With the same.
Angle ADC is also congruent to what angle?
RCB.
RCB, but alternating interior.
And CBA.
CBA. That's not alternating interior.
Oh,
Look, alternating interior on the inside. Yes. FC what? FCD. FCD. Exactly. Right here, alternating interior. Those are alternating interior. Now, what's this angle called? So you have your angle right here. Can you stop with the twitching? Thank you. That angle right there is also congruent to this angle right there. What's the relationship between these two angles called? Does anybody remember? Yes, opposite. Are opposite angles congruent? As long as they're lines, right? As long as they're not bent, are they going to be congruent? So then, if those are opposite angles, you know that this is congruent because it's alternating interior to go to there. So can you fill in lots of angle congruencies if you have parallel lines? Yeah, there's lots of angle congruencies. So going back here, if you have two triangles and you show that two pairs of corresponding angles are congruent, you've shown that the two triangles are similar. Or if you've shown that all of the corresponding side lengths are proportional, then the shape must be, the two shapes must be similar. Is this okay so far? We're good? Does side similarity work with a four-sided shape? Does side similarity work with a four-sided shape? What do you think?
I don't think it does.
Why not?
Because if you have a square and a parallelogram, then
the side lengths could be
all the same, but then
not the same. They could all be what? What's the word?
Congruent.
No.
Okay.
All the side lines could be. All the corresponding sides could be proportional. But does that mean they need to be in the same orientation?
No.
So, for example, here's a square. All the same side lengths, right? Here's another square. It's even bigger. Are they proportional? But could I do this? Could I bend that? Could I take this bigger square and bend it into a diamond? Sure. Same lengths, right? My question now is, if you have shape A here and shape B and shape C, I would agree. A is similar to B, but is A similar to C? No, it's not. So these rules right here only work for triangles. So are we going to stay in triangle land for a little while? Yeah. Are you happy to stay in triangle land for a little while?
Yeah.
Yes. And what was the key? I'm going to go back to the homework last night. One of the last questions was, the third question was, what about, I think I said a square. Did I say a four-sided shape?
Four-sided shape.
What was the key to any four-sided shape? What can you do with any four-sided shape? Any four-sided polygon, what can you do to it? What can you do to any four-sided shape? The first two questions had to do with triangles. What can you do with any four-sided shape? Yeah. Can you what? Tilt it. What do you mean by tilt? You could skew it, but I'm saying you're not changing the overall four-sided shape. But what could you do to the shape? Divide it into what? Divide it into two triangles.
Any four-sided?
Yeah, draw any four-sided shape. Let's make the craziest one I can think of. Ready? There's a four-sided shape, right? How many triangles do you see? Two. 1, 2, 3, 4. How many triangles do you see? 2. Now here's the thing. Ready? How many sides do I have now? How many sides? 1, 2, a lot, right? How many triangles do you see?
Does this work for any polygon?
Exactly. So, what can you now say?
Every polygon.
Any polygon?
Any polygon that is not abstract.
No, any polygon.
But if you have like
A polygon has straight sides. Any polygon can be what?
broken down into triangles.
Broken into triangles. So here's the thing. If you can copy a triangle, what does that mean?
You can copy any polygon.
Yeah, exactly. If you can copy a triangle, which means you can copy any polygon. Could it take a long time?
Yeah.
Yeah, it could take a long, long time, but does this prove it's possible? Yeah, it proves it's possible. Is that kind of cool? I have a question for you. Here's a math question for you. It's math class, so it shouldn't be too surprising. If I gave you a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12-sided polygon, so a 12-gon, what's the minimum amount of shapes, triangles you would need to break that apart into? Well, let's see how many we can do. Ready? 1, 2, 3, 4, 5, 6, 7, 8. I see 10. Is there any way to break it into fewer triangles? Not necessarily. What about if I gave you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15? How many triangles? Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 15 gone. How many triangles? 13 triangles. A 12 gone was 10 triangles. So the question, your guess could maybe be, if you had an n gone, how many triangles is that? N minus 2 triangles. Pretty cool, huh? Some neat stuff.
So 100 side shape has 98.
Yeah, be a lot of triangles. At least 98. At least 98. Fun stuff. Fun stuff.
But they can have more.
Sure. Well, you could break it apart into more if you want to. Whee! There's some more. There's some more triangles. There's even more triangles. You can make as many as you want. You know, we're looking for minimums, right? Minimums.
Yeah.